Let's continue with an example. Find limit x approaching infinity of 1 over x and limit x approaching negative infinity of 1 over x. Note, when x is large, 1 over x is small. Okay? For example, when x is 100, 1 over 100 is 0.01. When x is 10,000, 1 over 10,000 is 0.0001, so on. In fact, by taking x large enough, we can make 1 over x as close to 0 as we please. All right? Therefore, we have limit x approaching infinity of 1 over x equals 0. Similarly, we can say that when x is large negative, we also approach 0. Therefore, limit x approaching negative infinity, 1 over x is 0. Here is the graph of 1 over x. All right. Notice as x approaches positive infinity, your graph approaches 0. Likewise, when x approaches negative infinity, your graph height tends to 0. Okay. Here is a theorem, important. For any rational number that's positive, 1 over x to the r is 0. Okay, this is very important. 1 over x to the rational number. Rational number can be fractions, 1 over 3, 2 over 5, so on. So not just 1 over x, but 1 over x to any positive rational value, limit approaches 0. Okay, this is a major theorem. Which brings us to a nice example. Limit x approaching infinity of this quotient function. Okay, rational function. You have a polynomial upstairs, polynomial downstairs. Notice as x becomes large, numerator is going to infinity, denominator is also going to become infinity. So when it's infinity over infinity, you need to do something. All right. So what we do is divide both the numerator and denominator by the highest power of x. That occurs in the denominator. All right. We are assuming x is not 0. Okay. That's, you understand. I hope you realize you are going to divide by x. Well, you can divide by x as long as x is not 0. Well, we are of course not equal to 0 if we are approaching infinity, right? Going towards infinity. So we can divide by certain power of x. Which power? We take the highest power of x in the denominator. In this case, x to the power 2. Divide the numerator by x to the power 2. Divide the denominator by x to the power 2. Don't forget to carry over limit x approaching infinity. Okay, don't forget to write that expression. Continuing, look, division distributes. So x squared cancels the x squared, you have 3. This gives you minus 1 over x, and this gives you negative 2 over x squared. Likewise, here, x squared cancels the x squared, you have a 5. This gives you 4 over x, and this gives you 1 over x squared. All right. Don't forget, division distributes, because division is nothing but a certain kind of multiplication by the reciprocal. Okay. All right. So we finished the division. Now limit goes upstairs, limit goes downstairs. Okay. Once that happens, limit of 3, then limit of minus 1 over x and limit of minus 2 over x squared. Likewise, limit of 5 plus limit of 4 over x, limit of 1 over x squared. Okay. So notice that 4, they can move it outside. Likewise here, that 2, they moved it outside. Oops. So what that gives me, look, limit of 1 over x, limit of 1 over x is 0. Limit of 1 over x squared, limit of 1 over x squared, that's also 0. All that survives is 3 over 5. Okay. So this limit is actually 3 over 5. Here is a graph, okay, of the same function at 3 over 5 from the right and from the left. Okay, so for the left you will need to do similar calculation, is the same argument, and you get limit equals 3 over 5, which is 0.6. Okay. Example 4. How do we find limit of this? Okay. The question now is horizontal and vertical asymptotes. Okay, so these are two different features. Okay. First, let's worry about limits, okay, to the infinities. Divide by the highest power of x in the denominator, which is x. So you divide the numerator by x, divide the denominator by x. Okay. So look, numerator had a square root there. X is outside the square root. So when I take it inside, it becomes x squared. You see, square root of x squared is x. All right. So now this is inside. This is as it is. For numerator and denominator, you can distribute the division. All right. Here is an important note. Square root of x squared is x for x greater than 0. That's important. All right. If x were negative, you would need a negative there. All right. Right now, x is positive because you are going to positive infinity. These two cancel, you get a 2. These give you 1 over x squared. Likewise, these two cancel, you get a 3. And this gives you 5 over x. Now you start take limits. Limit of constant survives. Okay, but 1 over x squared and 1 over x, they go to zeros. So they don't survive. So square root of 2 upstairs and 3 downstairs. Okay, now y equals square root 2 over 3 is horizontal asymptote, but this is on the right hand side. What happens to the left hand side? When x approaching negative infinity, you must remember square root of x squared is negative x. When x is going to negative infinity, the point is square root of x squared is always absolute value x. Think about it. If x were negative 3 becomes positive 9 with the square, then square root gives you positive 3. So what you had negative inside became positive outside. So if x is negative, minus of x would be positive. That's why. All right. So do remember, when x is negative, square root of x squared is absolute value x, which is negative x. Okay. So here you will need to make some changes. So let's go to the original expression. You have x here. You have negative x squared, you see. So there a negative comes out, and then x squared goes in, and so on. All right. Which brings me to a negative root 2 over 3 as the limit. All right. So therefore, because the left limit, so limit x approaching negative infinity is negative root 2 over 3. This is also a horizontal asymptote. Okay, so we got two horizontal asymptotes. What about the vertical asymptote? To find vertical asymptote, you always look at the denominator. You set that to 0. When you set that to 0, you get x equals 5/3. Okay, 5 to the right hand side divided by 3. All right. So if x is close to 5/3, then the denominator is close to 0. Okay, the numerator is fine because of x squared. Whether x is positive or negative, this quantity is positive plus 1 square root is just some number. But the denominator hitting 0 gives you a positive infinity because we are going to positive here. Okay, this is an important thing to note. When x is approaching 5/3 from the right, take an example. Say 5 over 3 is what? 1 and 2/3, that is 1.66666. So take x equals 2. When x is 2, you get 6 minus 5. That's a positive number. Therefore, you get positive infinity. Numerator, mind you, is always positive. All right. But when x is to the left of 5/3, then what happens? So left of 5/3, remember what was 5/3? 1.666. So take a number less than 1.666, say 1. 3 times 1 is 3 minus 5, negative 2. That's a negative. So limit x approaching 5/3 from the left hand side gives me a negative infinity. Okay, this is incredible. So you have another, you see, the limit is approaching negative infinity. So somewhere here is 5/3. When you approach 5/3 from the right, you're going to positive infinity. When you approach 5/3 from the left, you go to negative infinity. And here are the two horizontal asymptotes. Limit x approaching infinity gets you root 2 over 3. Limit x approaching negative infinity gets you negative root 2 over 3. So you have two horizontal asymptotes and one vertical asymptote. Okay. Until next lesson.